Assalamualaikum warahmatullahi wabarakatuh. Hello, we from Group 1 will deliver material about mathematical models related to extreme values of function. Before that, introduce my name is Elda Krismawati and my friend Arsita Stiarnasari. Okay, welcome to my class. Let's we start our lesson today. Derivative applications determines the slope of the tangent to a curve. The slope of the tangent m on a curve y is equal to fx is defined as m is equal to the derivative y is equal to the derivative fx. The equation of the tangent to a curve y is equal to fx at the point of tangent x1, y1 is defined as y minus y1 is equal to mx minus x1. M is equal to the derivative fx1. Determine the interval for the ascending function and descending function. The condition for the interval of the function increases the derivative fx greater than 0. The condition for the interval of the decreasing function is the derivative fx less than 0. Determines the stationary value of a function and its type. If the function y is equal to fx is continuous and differentiable at x is equal to a and the derivative fx is equal to 0, then the function has a stationary value at x is equal to a. The type of stationary value of the function y is equal to fx can be a minimum return value, maximum return value, or inflection value. The type of stationary value can be determined using the second derivative of the function. Number 1. The maximum value of the derivative fx is equal to 0 and fx less than 0. If the derivative fx1 is equal to 0 and the derivative fx1 less than 0, then the derivative fx1 is the minimum return value of the function y is equal to fx and point x1. Fx is the maximum turning point of the curve y is equal to fx. Number 2. The minimum value of the derivative fx is equal to 0 and fx greater than 0. If the derivative fx1 is equal to 0 and the derivative fx1 greater than 0, then fx1 is the minimum return value of the function y is equal to fx and point x1. Fx is the minimum turning point of the curve y is equal to fx. And number 3, the inflection value of the derivative x is equal to 0 and fx is equal to 0. If the derivative fx1 is equal to 0 and the derivative fx1 is equal to 0, then fx1 is the inflection value of the function y is equal to fx and point x1. Fx is the inflection point of the curve y is equal to fx. Stationary value. In the material of increasing and decreasing function, we know that if the derivative f(x) greater than 0, then the function increases, and if the derivative f(x) less than 0, then the function decreases. What about if the derivative f(x) is equal to 0? A function will reach optimal, maximum, or minimum if its slope is equal to 0, m is equal to 0. Since the slope is equal to the first derivative of the function, the first derivative of the function is 0, the derivative f(x) is equal to 0. This point is represented by a stationary point. Mathematical models related to extreme values of function. In this section, we will discuss about simple examples of the applications of stationary values to solve problems maximum and minimum values known as the extremes of the function. The approach of the solution in a mathematics formula known is the mathematical model. To complete the extreme function problem, use these following steps to solve the problem. Number 1. Use a letter or specific alternative to represent all attributes or factors involved. Number 2. Formulate all relationships of the problems. Number 3. Formulate factors to be maximized or minimized function of another factor, or write mathematical model of a function in one variable. And number 4. Determine the maximum or minimum values of the results on the step 3.
Let me continue our discussion. To make it easier to understand the maximum and minimum values, let's see the example. Example 1. The sum of two numbers equal to 20. Determine the two numbers so that the product is maximum. And the answer, step 1, describe the two numbers into variable. The first number is A and the second number is B. So the model of the sum will be A plus B equal to 20. Step 2, by using multiplication, the mathematical model will be A multiplying by B. Step 3, remember that we should change into one variable only and execute by using derivative form. A plus B equal to 20, so A equal to 20 minus B. Continue step 3. Substitute the value of A into the multiplication, the product. A multiplying by B equal to, in the bracket, 20 minus B from here, and multiplying by B equal to 20B minus B squared. The product of two numbers can be presented as a function of B. Function of B equal to 20B minus B squared. Step 4. The function of B reach out the stationary of the derivative of function B equal to 0. If the function of B equal to 20B minus B squared, then the derivative of B equal to 20 minus 2B. So 0 equal to 20 minus 2b. Step 5. Find the value of b. 20 minus 2b equal to 0. We can change 20 to the right side, so 2b equal to 20 and b equal to 10. Step 6. By using a plus b equal to 20 and the value of b equal to 10, so we can find the value of a as a plus b equal to 20, and we know that the value of b is equal to 10, and the value of a equal to 10. Step 7. From this step, we find the value of a equal to 10 and b equal to 10. So the sum of two numbers equal to 20 and the products is maximum are 10 and 10. Next, example 2. A rectangle has a length in the bracket 5x plus 5 centimeters and a width 5 minus x centimeter. How to find the maximum area of the rectangle? The answer, step 1. Define the formula for the area of a rectangle. A equal to length multiplying by width. Step 2. We know that length equal to in the brackets 5x plus 5 cm and width is equal to 5 minus x centimeter. Substitute the length and width into the formula. We can substitute length and width, so the area equal to 25x minus 5x squared plus 25 minus 5x. So a equal to minus 5x squared plus 20x plus 25. Step 3. The function condition of a reach out the stationary of the derivative of a equal to 0. If a equal to minus 5x squared plus 20x plus 25, then the derivative of a equal to minus 10x plus 20. So 0 equal to minus 10x plus 20. Step 4. Find the value of x by using change 20 to the right side. Minus 10x plus 20 equal to 0, and we can change 20 to the right side. Minus 10x equal to minus 20, so x equal to 2. Step 5. Determine the maximum area by using mathematical calculation. A equal to length multiplying by width. We know that length r is in the bracket 5x plus 5 multiplying by width 5 minus x, and we know that the value of x equal to 2. We can substitute here. A equal to 5 multiplying by 2 plus 5 and multiplying by 5 minus 2. A equal to 15 multiplying by 3. And we can get the area of the rectangle is 45 centimeters square. Step 6. From the step, we find the value of x equal to 2, so the maximum area of the rectangle is 45 centimeters square. I think enough for our presentation. Thank you for your attention. If you have any question, please write in the comments column. See you class. Wassalamualaikum warahmatullahi wabarakatuh.